AC Electronics. So the examination date for LPSC Technical Assistant is out. The admit card is out and it is on the February 23rd. So the examination is very nearby and it is time for you to speed up your preparations if you have applied for the LPSC Technical Assistant post. Okay, so from today onwards we'll be doing various formula revision videos. For that it will be easy for you to revise all these formulas and it is easy for you to write the examination. Okay, so this is a formula revision video of network analysis in which we are going to discuss some of the very important equations of network analysis and network theorems. Okay, so let us see what are the important equations. Starting from the very basic equations, the equation for current, you all know the equation for current. It is current I is equal to dq by dt. We know that current is the rate of change of charge or rate of flow of charge is called current. So here current I is given by dq by dt and the unit of current we all know it is ampere. Okay, next equation, the current for charge. So from this differential we are actually finding the equation for a charge is equal to integral I dt, that is t0 to t I dt. Or you can also write the equation in terms of capacitance that we will discuss later. Anyway, so this is the, if you know the current and the rate of flow of current, you can find the value of charge. Next equation, power. We are going to discuss about power later on. Anyway, the basic equations are, see, these equations are very important for technical assistant post and also for gate exams also. Because if you don't know these equations, sometimes the end result you have to find the power. So you simply have to multiply voltage and current. So power P is equal to V into I, or if I is not directly given, you can use the equation V square by R if you have the resistance value, and if you know the current and resistance, you can apply this equation I square into R. So these equations are very important. Okay, next we are moving on to the various components of network, that is resistors, capacitors. So before going into that, there are the elements of a network can be classified basically as two types, active elements and passive elements. Why I am saying this is because I have seen a lot of questions coming from the type of elements, active element or a passive element. So there are basically two type of elements in a network analysis or a network. Okay, so we can also classify them as various types, that is unidirectional, bidirectional, linear, non-linear. Anyway, based on the power consumption, the elements of a network can be classified as two types, that is active elements and passive elements. Active elements means the sources. The generation of power is done with the help of active elements, or they generate power. For example, voltage source, current source are examples of active elements, or also transistors. They also give or generate some type of power. So they are called active elements. Whereas the other type of elements are called passive elements, where in which these elements doesn't generate any power. For example, a resistor. Have you ever heard that the power is created by a resistor or an inductor or a capacitor? Capacitor simply stores charge or store energy in terms of energy, if you say. So the passive elements doesn't generate any energy or any power, whereas they only consume. So these resistors, inductors and capacitors are passive elements, whereas the voltage source, current source means generation of power or generation of energy or current or voltage. So they generate something and they are called active elements. So this category should be clear to you, that is active elements and passive elements. And now we are going to discuss about the equations of various components such as resistors, capacitors and everything. So I have included only the very important equations. I have not included, or I have not stuffed in all the unwanted equations, because it is difficult for you to study, right? So if you are going for an N-type preparation, these type of formulas are important for you. So first element, we know that resistor. Resistor's function is to resist the flow of current. The equation for voltage in terms of resistance, this is called the very famous Ohm's law. V is equal to I into R. The product of voltage is the product of current and resistance given a constant or room temperature. Anyway, let us not go into the theory part. We know we only need this equation to find the voltage V is equal to I into R. Now, in terms of the time domain, or if it is a time varying voltage, then Vt is equal to R into R is a constant value, that is a resistance. R into I of T, that is current. Current is also changing with respect to time. So, V of T is equal to R into I of T. Equation for the resistor or resistance value in terms of the resistivity, length and area of the conductor. That is, we are going to talk resistance specific to a material or a conductor. So, here the resistivity is given by rho into L by A. That is rho into L by A, where rho is the resistivity, L is the length of the conductor, A is the area of cross section. So, this is the equation for resistance in terms of rho L by A. Now, why I am also specifying these type of equation, because sometimes in question papers, they will be asking the relation between the resistance and area, or consider that they will be giving the value of radius of a conductor, and then they will be asking that if this resistance has reduced by this times, or if this resistance if this radius is increasing by this times, how will the change happen to the resistance? They will be asking. Such type of questions can also come. So if you study these formulas, you can answer the relationship questions. Okay, so that is all about the resistor. Next, going on to the capacitor. We know that capacitor is a device or a component used for storing of charge, and the unit of this capacitance is given by farad. So I am not writing all the units. You know that the resistor unit is ohm. Okay, and the capacitor unit is farad. Next, I have already told we can write the charge equation in terms of capacitance and voltage. Q is equal to C into V. Okay. Also, IT is equal to C into dV by dt. In terms of voltage and capacitance, we can write the current I is equal to C into dV by dt. Also, voltage V of t. So, here we are considering time variant components. So, Vt is equal to 1 by C into integral minus infinity to t it dt. Okay. So, you can also write this as 1 by C integral it dt, or I into IDT you can also write. Okay. So, anyway, we are considering the time variant components here. For example, current, voltage, etc. Capacitance will be anyway a constant value. Okay. Next, if you write this capacitance in terms of frequency domain equations as voltage and current relationships, then V is given by 1 by j omega c into I, where omega is the angular frequency which is given by 2 pi into normal frequency f. Okay, I is current, V is voltage, you know that. Then C is a capacitance. Okay, in terms of the impedance of the material, of the component, if you write, then Zc is equal to, that is capacitive impedance, is equal to minus J into Xc, where Xc is the capacitive reactance, and Xc is specifically given by 1 by omega c. Okay, so this is the all equations in terms of impedance, in terms of time variant components, and in frequency domain. Okay, next is the another important equation. The energy getting stored in a capacitor is given by E is equal to C into V square by 2. Okay, so that is the equation for capacitor. These are the equations for capacitors in terms of network analysis viewpoint. Okay. Now, let us move on to the other elements such as inductor, and also let us see the relationship of series and parallel connection of these resistors, capacitors and inductor. Next is the equation for inductor. So, for inductor, we know that the unit of inductance is Henry. So, the equation in terms of voltage, V of t is equal to L into di by dt, and in terms of current, I of t is equal to 1 by L into minus infinity to t, that is integral minus infinity to t, V of t dt. So that is the equation of inductor in terms of voltage current relationship. And the energy getting stored in the inductor is given by E is equal to L into I square by 2. So these are also important because, as I told, sometimes the end question will be finding the energy of an inductor or energy getting stored in the inductor. Okay, so this is the important equations, and the unit of inductance is Henry. Next, let us move on to a very important session. That is, a lot of questions can come from this area. Series and parallel connection of resistors, capacitors and inductors. Now, I have clubbed these equations in a term that is easy for you to study. So, let us first talk about very important resistor connection in series. So, when resistors are connected in series, how will the total resistance can be calculated? R1 plus R2 plus R3 plus n number of resistors if connected in series, taking all the sum of those resistors. Now, in parallel, what will be the relationship? It is 1 by R is equal to 1 by R1 plus 1 by R2 plus, for n number up to 1 by Rn you can add. And if there are only two resistors, what is the equivalent resistance value? R, you don't have to write this equation. R equivalent is equal to, if there are only two, R1 R2 by R1 plus R2. This is also important if you are only having two resistors connected in parallel. Okay. And also consider that there are n number of resistors of identical resistance connected in parallel. That is, for example, 1 ohm, again 1 ohm. All these resistors are connected in parallel means, I am just taking this as 1 ohm. Say it is a R ohm. N number of R valued resistors in parallel connection, then R by N is the equivalent. R equivalent is equal to R by N. For example, if 10 100 ohm resistors are connected in parallel means 100 by 10. Okay. So 100 is the value of each resistance and such 10 resistors are connected in parallel, right? So 100 by 10. I hope it is clear. If you are noting down, please note down these equations also, because they are also very important. Next, consider that n number of resistors of identical value are connected in series. Total resistance is n into R. R equivalent is n into R for series connection. Okay. So, this is the relationship. Now, so we have talked about the resistors connection in series and parallel. Now, let us move on to the inductor. So, this I have written inductor after resistance because the equation is identical. So, you can easily study. So, for inductance also, series connection equation is L effective, or L is equal to L1 plus L2 plus etc. up to n numbers. And also for parallel connection, it is 1 by L is equal to 1 by L1 plus 1 by L2 plus 1 by L3 plus etc. up to n numbers connected in parallel. Now, for capacitor, this equation is in reverse. For series connection, equivalent capacitance is 1 by C is equal to 1 by C1 plus 1 by C2 plus 1 by C3 plus etc. And also for parallel connection, it is simply C is equal to, this C means equivalent value, is equal to C1 plus C2 plus C3 plus etc. So, I have told that when n number of resistors connected in parallel, if having identical value, you can take R by N. Similarly, this case is also applicable for inductors and capacitors. For example, if n number of inductors are connected in parallel, right? Okay, so if n number of inductors of identical value, say it is L Henry. So, L by N is the equivalent inductance. Similarly, for capacitor in the series connection also, consider if capacitors, if C, all these capacitors are having C value, and if there are n number of capacitors means the equivalent capacitance is C by N. See, this is the series relationship. Series relationship is 1 by C is equal to 1 by C1 plus 1 by C2 plus 1 by C3 plus etc. So, this what I am telling about NC and C by N type of for identical elements, that can be inductor or resistor or capacitor. For identical elements, this equation is applicable for all the resistor, inductor and capacitor. I hope the concept is clear to you. Okay. So, anyway, this is a general equation for finding the equivalent values of resistors, inductors and capacitor in terms of series and parallel connection. So, I hope it is clear. Next is the RLC network, that is series and parallel RLC, resistance, inductance and capacitor, connected in series and connected in parallel. Okay, so before going into that, I have to explain one more concept. In the series and parallel case, consider any network. In any network, in series connection, what happens is that the voltage is getting divided. Okay, in series, voltage is getting divided, and current is same for a series connection. And also, in parallel connection, what happens is that in parallel, there will be various branches, right? So, through these various branches, the current will be different for various branches and the voltage is same for this parallel case. Okay, so in parallel connection, voltage is same, current is different. In series connection, voltage is different, current is same. So, you have to also know this concept. Okay, so next move on to the RLC network. So, this is a series network, this is the parallel RLC network. We are talking about the impedance. So, for a series RLC network, the impedance in complex term is given by Z is equal to R plus J omega L plus 1 by J omega C. So, we are taking the impedance of all these elements, resistive element, capacitive and inductive element. And if you take the absolute value of impedance, Z is given by square root of R square plus omega L minus 1 by omega C the whole square. This is the relationship. So, if you are preparing for any competitive exam, please note these equations down. Okay, this is anyway very useful for you. He said in terms of the parallel connection, the complex equation is given by 1 by R plus 1 by J omega L plus J omega C, and the absolute value is given by Z is equal to 1 by square root of 1 by R square plus 1 by plus omega C minus 1 by omega L the whole square. Okay, so these are the equations, and the most important equation is the absolute equation, because they will be asking only the absolute value of impedance or absolute value of impedance for series or parallel connection. Okay, so this is the RLC network in series and parallel connection. Next is the equation for transformer. So, transformer is also very much important for network analysis. So, transformer, why they are been using transformer, can be used for the step up purpose or step down purpose. Okay, step down transformer. So, anyway, the transformer consists of two areas. There is a primary winding, primary inductor coil and secondary inductor coil. Let N1 be the number of turns present in primary, N2 be the number of turns in secondary. I1 is the current in the primary area, I2 is the current in the secondary area, V1 is the voltage in primary, V2 is the voltage in secondary. Now, if N1, the number of turns of the primary, is greater than N2, means we are actually going to reduce the voltage. We have heard about the terms called step up transformer and step down transformer, right? Step up transformer, they will increase the output voltage, whereas step down transformer will try to reduce the output voltage at the secondary. We are taking the output value at the secondary side, input value we are applying to the primary side, right? So that is a concept of a transformer. So anyway, if N1, that is the number of turns of primary, is greater as compared to secondary, means we are trying to reduce the voltage and it is a step down transformer. And if N2, that is the number of windings of secondary, is greater than primary, means it is a step up transformer. So we are trying to increase the voltage. Now the relationship between V1 by V2 and N1 by N2 is given by V1 by V2 is equal to N1 by N2. Relationship between I1 and I2 and N1 and N2 is given by I1 by I2 is equal to N2 by N1. So this is the relationship between the number of turns and voltage and current. Okay, and the ratio N1 by N2, that is number of turns of primary to number of turns of secondary, is given by turns ratio. Okay, also in each of these areas, there is an inductor in the secondary coil, and in the primary area there is also an inductor. So we know the voltage getting generated. We have already discussed about the voltage current relationship of inductor. So that is also applicable here. Okay, so this is all the important equations for transformer. So I hope the concept of step up and step down is also now clear to you. Sometimes they may ask this relationship. If the winding of primary is greater than secondary, then what type of a transformer it is? In technical assistant examination, you can expect such questions. Okay, next is the RMS. When you have to find the RMS value of voltage and current, the relationship is VRMS is equal to Vm by root 2, where Vm is the maximum or the peak voltage value. IRMS is equal to Im by root 2, which is there again Im is the peak current value. So in order to find the RMS value, sometimes they'll be given only the peak values. You have to use the RMS value, because we know that sometimes in order to find the RMS power, PRMS is equal to IRMS into VRMS, right? So sometimes you have to use these equations. So for that purpose, you have to take the RMS values also. So for that you need this equation. So these are the all important equations for the basic network analysis. I have not gone into the theorems. There is a lot of theorems in network. There is mesh analysis, there is nodal analysis, all these things are there. So please go to the playlist of network analysis, in which I have explained about a lot of questions as various parts, and also specifically I have done videos for nodal analysis, Thevenin's theorem, and also delta to Y conversion, and all those theorems we have discussed. So if you want to watch all those equations or all those areas or theorems, please do watch those videos, okay? And also I would suggest you to please watch the numerical videos. There is 3 parts of numerical videos in which I have included various questions or problems from various areas of the network analysis. So please do watch that also. It will be very, very beneficial for you. And also, if you found this video useful for your preparation, you might be preparing for a lot of exams coming on the electronic area. That is for technical assistant. Also, there is also DMRC, BARC examination, and there is a lot of examinations coming. So if you are preparing for any of these examination, I think that you found this video useful. Please, my request is that please note these equations down. Okay, so if you have noted these equations, my request is that try to prepare a note for each subject. Try to prepare the important equations note, so that if it is the examinations last night, you can refer these equations, and it is very useful. Rather than just going on through your notebooks and finding all the equations, it is very tedious task. If you have prepared a formula revision book from earlier, it is very, very useful for you. So that is my request or my suggestion for you. Anyway, you can have your own idea of preparation, right? Okay, so anyway, if you found this video useful, please do give it a thumbs up, and also share this video with maximum of friends. And please do tell your friends to subscribe to the channel, okay? And if you found this video useful, please you also subscribe to the channel. And if you want more videos also, please keep on watching to Easy Electronics. Thanks for watching, and keep on watching.